title in your books, remember, write in black ink and underline with a straight edge. So you can use a ruler or your ID card. So I'll let you do that. And then we'll have a discussion about groups and periods on the periodic table. Okay, so last lesson, we looked at the periodic table and we in particular looked at metals and non-metals. And I believe I've got you to draw this line in to separate the metals and the non-metals. So we've got metals on the left of that line. So we've got metals over here. And we've got non-metals on the right. Well, today we're going to look at two other aspects of the periodic table. One is groups and the other is periods. So let's start off by looking at the groups. So on your periodic table, you should have the groups already labelled for you. So there should be big numbers at the top here that say 1, 2, and then 3, 4, 5, 6, 7, and 0. It might say 8 at the end, it might say 0. I think actually on the one that I gave you, it says 0. Right? So what I want you to do is to highlight those, put a circle around them or something, and just call them the groups. So these are the group numbers, these numbers along the top. So highlight them in some way. They are the groups. So basically, they are columns. So they go up and down. So group 1 is there. Everything in that column. So lithium, sodium, potassium, rubidium, cesium, and francium. That's all in group 1. Okay. Everything in this group is in group 2. Then you've got these things in the middle, which we'll come on to in a moment. And then you've got group 3, which starts at boron and goes down. 4, 5, 6, 7, and group 0. Okay. So they are the groups. Okay. So they are the groups, groups 1 to group 0, and we'll explain what they mean later on. So they're the groups, okay? Right, and there's a couple of groups we're going to look at in a bit of detail in this topic. One I've already mentioned to you, which is group 1. So just circle everything in group 1. Yeah. In a different colour if you've got it. If you haven't got a different colour, it doesn't matter. And we'll call those the alkali metals. So put a label somewhere. Group 1 are called the alkali metals. So they're called the alkali metals. And then the other couple of groups we're going to look at, we're going to look at group 7, which should be fluorine, chlorine, bromine, iodine, astatine. All right. And there's one underneath it, which I believe is tennessine. or it might say something else on yours if it's an older periodic table. Okay. So that's TS. Okay, so that's another group we're going to be looking at. If you've got a different colour, great. If not, just do it in a different shade or different pattern. So I'll do a dashed line around each one. Yeah, and we're going to call these are called the halogens. Okay, so that's group 7 is called the halogens. The reason why I've put a bit of space there is because I'm going to look at group 0 as well. So we're going to look at group 1 in a bit of detail, which is the alkali metals. We're going to look at group 7 in a bit of detail, which is the halogens, so fluorine down to tennessine. And the other ones we'll look at, I'll do these in black, we're going to look at the noble gases. So we've got, it should say helium, neon, argon, krypton, is it xenon then radon? Yep, and then organosine. So xenon, radon, and then og. Okay. And we call these the noble gases. So these ones, I'm just going to put a big arrow under them. We call those the noble gases. Okay, so groups go up and down. They go up and down the periodic table. So we've got group 1, group 2, group 3, 4, 5, 6, 7, and 0. And what you'll learn is, all right, is that each element within a group, so all of these red ones, for example, will behave, and I'll explain what that means in a moment, in a similar way. So that just means that they will react. And when I say react, it just means they'll interact, they'll start causing sparks, they'll start producing gases with the same material. So I know that all of these, for example, when I throw them in water, they react in a very similar way. And that's how the periodic table has been organized. It's been organized so that atoms, or elements, sorry, let's use the word elements, with similar characteristics or properties, how they actually behave, have been grouped together. So we've got lithium down to francium, for example. I know they behave in a similar way. And that's true for all groups. So I could just look at group 7, fluorine, chlorine, bromine, iodine, acetine. I know that all of those behave in a very similar way. And that's what periodic means when you talk about the periodic table. It's been organized by, there's method to it. It's not just a collection of different pieces, right? There is actually an order to it. So they've been grouped together by how they behave, how they react with other chemicals. And the same for group 0, which is the noble gases. They all behave in a very, very similar way to each other, which is not very much. They're very unreactive, and we'll explain why later on. So they are the groups. Okay, what we need to label now are the periods. So if the groups go up and down, so group 1, group 2, group 3, 4, 5, 6, 7, and group 0, before we move on, I will explain this middle bit. We might as well label these. So it starts at scandium, goes to zinc, and then goes all the way down. So this bit here we call the transition metals. So I'm just going to put a box around that. These are called the transition metals. So these are your common metals that you might come across in everyday life. So things like iron, you might have come across before or heard of. Things like chromium, things like gold, silver, platinum, copper, all things you might come across in everyday life. These are the transition metals. And even still, all right, as hopefully we'll find out in a video later, if we look at where copper is on the periodic table, so copper, silver, gold, which is there. So if we look at copper, silver, gold, even they have pretty similar properties. So if we look at those as like a separate group, if you like, they still have very similar properties. And they're used in the same sort of industry. I'll wait there. So just waiting. Let me know, Mr. Howe, when I can continue. I'll have a quick drink. Yep, so just let me know when I can continue. So they're the groups of the periodic table. These other groups have got names, but we don't need to know that. The black line between lanthanum, so that's runs there, isn't it? Yeah. Well, that's like there's another 20. There's an extra 28 elements that fit in that gap. You'll notice the way that the elements are actually numbered. It goes sort of like 57 there to 72 there, and then it goes from 89 to 104. Well, it just means there's actually 14 elements in that gap, and there's 14 elements in that gap, which do exist. They're just not on your periodic table. But like I said last week, I will get you, all right, a periodic table which has all the elements on, so you can have a full picture. So they're the groups then. Groups up and down, up and down, up and down, up and down. So what do you think the periods are then? The periods are the rows. So they go from left to right. So groups up and down, up and down, up and down. Periods left to right, left to right. So let's have a look here. So the first period, you've got to be careful here. I'm just going to get rid of this label of alkali metals. The first period is actually, so I'm just going to put this in let's put it in a triangle. Has only got hydrogen in it and helium in it. So they're the only elements on period 1. Period 2, so I'll do all these in triangles, is underneath, and that goes from lithium all the way across to neon. Don't highlight these, don't colour them in. I'm just going to put the key numbers here. The next one is period 3, then period 4, and period 4 is from K, which is potassium, all the way to Kr, which is krypton. All right. Color. So that's period 4. Period 5 is there, which is rubidium or Rb, all the way to xenon, Xe. And then we've got period 6 and period 7. So we need to put a key here somewhere. These are called the periods. So periods go across the periodic table. Groups go up and down. Okay? Let's come out of the way. Okay. Now, before we actually move on and start putting some things into our books, all right, we're going to just talk about how they actually are arranged in these rows. So again, focusing on, you'll notice there's two numbers in each box. So if I take lithium, for example, lithium has got a number 3 there and a 7 there, and it goes all the way across to fluorine, which has got a 19 there and a 9 there. All right. And I don't want to focus on both numbers. I just want to focus on the top number. And the top number is called the mass number. And the mass number is effectively how heavy each element is. So don't worry about units or anything like that. All you need to know is the trend, because the periodic table, you'll notice trends or patterns in it. And hopefully you can see that the atoms are actually getting, just look at the top numbers if you go from left to right. Hopefully you can see the top numbers are all getting bigger as you go from left to right. So the atoms are getting heavier. And again, you should, any row you read across, just read any row from left to right, look at the top number, and hopefully you can see that the top numbers are getting bigger, which means the atoms are getting heavier. If we were to do that down a group, so let's look at group 1. If I put all the mass numbers in, so we've got 23, we've then got 39, 85, 133, and 223. So if we just focus on those red ones for a second, as we go down the group, so we're going down this group here, the atoms, the top numbers, the masses, sorry, are getting bigger. So the atoms are getting heavier. And we can do the same for any group. If you go down any group, even these in the middle of the transition metals, go down any group, and hopefully, fingers crossed, you see the same pattern. So as you go down the group, you can see the same pattern, that the atoms are getting heavier. I'm going to give you 60 seconds now just to have a look at the periodic table. So start looking up and down. Are the atoms getting heavier as you go down? And are they getting heavier as you go from left to right? All right, so just have a look at that. I'm going to give you 60 seconds. Go. Forty seconds left. Any questions you've got, just type into the chat before I move on to the next bit. Ten seconds. 3, 2, 1, and 0. Okay, so that's just an overview of the periodic table. You see, all the periodic table is a group of all the different atoms which make up the universe, and they're grouped together by how they behave, all right? And they go up in order of how heavy they are, all right? Not technically true. There is something else as well. The bottom number is how they're organized. So you can see here, that is number 1, that is number 2. Just look at the bottom numbers now. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's how they're actually organized in rows by the bottom number, and we call the bottom number the atomic number. I'll put in brackets what it says. It says proton. And we'll do a bit more about this next week, in that the atomic number tells you what the element is. So I know that if I find an atom and I count the number of protons it's got, let's imagine, just pick a number, I've got 7. If I find an atom which has got 7 protons, I know that it must be a nitrogen atom, which hopefully that is nitrogen on the periodic table. I know if I find an atom and it's got 17 protons in it, so the bottom number 17, which will take me there, I know that it's chlorine. Yep, pausing briefly, that's absolutely fine. So just have a look. How is it organized? This is a good chance to just look at the periodic table, all right, and ask any questions you might have about it. So it goes up, that's how they're organized, the bottom number, the number of protons it has. So each of these is a type of atom, and they've each got different numbers of protons. Okay, let me know when you want to continue. So I'm still here, just letting you guys have a look at what I've done. So again, we'll pause. Any questions you've got now is a good time to ask it. We've only got 15 minutes left, so I've given you quite a lot of information just there. So just let me know when you want me to continue, and I shall. Brilliant. So what we're going to do now then is, guys, just very quickly, all right, we're going to focus on melting points going down a group or across a period. So I'm just going to get rid of all of this because I don't need it. I'm going to keep group 1 because I'm going to use group 1 as an example. There we go. And group 7 as well. Okay, so I'll even get rid of group 0. So, okay. So what I'm going to do is I'm going to put some data on here. So we've got lithium, and I'm going to write down their melting point. Now, melting point is the temperature at which it becomes a liquid. So a bit like ice becoming water. We know that ice melts at 0 degrees Celsius, all right, or water freezes there. So anything above 0, ice will start to melt, and you've got liquid water. So I'm going to write down the melting points of these things. So lithium has a melting point of 180 degrees Celsius. So I'll be able to turn this into a table. And we've got sodium, which is 98, potassium 63, rubidium 39, 28, and 27 for francium. So they are the melting points of the group 1 metals. I'm going to do the same for the group 7, the halogens. So I'm just going to put melting point here. Degrees C. Okay. And then I'll write the numbers in again, and I'll explain what I want you guys to have a go at. So we've got here minus 220, so that's very cold, minus 100, minus 10, 110 degrees, 340. Yeah. And I'm going to leave a question mark here. Okay, so what I've done is I've just taken two groups, and groups up and down, up and down, up and down. They are columns. Yeah. And what I've done is I've put down the melting points. The melting points going down group 1 and the melting points going down group 7. So what I want you to do is I want you to make two sentences. So the first sentence is for this data. As you go down group 1, the melting points, and then finish the sentence. So as you go down group 1, which is this one here, the melting points, you tell me. All right. Increase, decrease, stay the same. All right. And then second sentence, as I'll do it in a different color, I'll do it in black. As you go down group 7, the melting points, and then finish the sentence. Okay, so you're going to write two sentences, and then the final sentence I want you to write is about this question mark. I predict the melting point of Tennessee is, and then put a number in there, and then why do you think this? I think this because. Okay, so hopefully that makes sense. All I want you to do is, I don't want you to write all this data out unless you really want to. All I want from you is just 3 sentences. I'll leave the numbers here. As you go down group 1, which is, don't forget, that group, what happens to the melting points? As you go down group 7, which is that group, what happens to the melting points? And then the final one is the tricky one. I predict the melting point. So again, it's all about patterns. It's all about trends. What do you think the melting point of Tennessee, which is this one, is? So look at the trend and come up with a number with a reason. Why do you think that? Okay. So I'll give you 4 minutes to get those 3 sentences done. 5 minutes, I'll get it. 5 minutes to get those sentences done. So it's 4 sentences in total. 1, 2, 3, and then why do you think that? So I'll give you another couple of minutes. Share your answers with people around, have discussions. Everyone needs to get those sentences written down. 2 more minutes, and then even if you're not finished, I'll have to stop you so I can go through it just before the end of the lesson. As you finish those, start thinking about the patterns down each group and try and think some reasons why. What's different about the 2 groups? Look at the periodic table, look at what you've labelled them as. What's different about them? "30 more seconds." And all right, put your pens down, put your pens down. Let's have a quick review of that. So, thank you very much. So, answers. Let's see what you should have put. So as you go down group 1, so that's down these numbers, the melting points decrease. Decrease just means they get smaller and smaller. So going down group 1, the melting points get smaller. But have a look here. This is slightly trickier. Going down group 7, we're going from negative numbers to positive numbers. So these numbers are actually getting bigger. They are increasing. So they increase down group 7, but decrease down group 1. And that's a trend. They are trends there. And we can apply those trends to other groups. I'll explain in a moment. And this one here, I'll accept any answer. And this is true if you ever did a test or an exam. For this question mark here, I predict the melting point of tennessine is any number which is bigger than 340 will get you the mark. So any number bigger than 340. So I just might put, I don't know, 370, for example. All right, any number bigger than 340, because that's the trend. These numbers, look, are getting bigger. So this next one must be bigger to carry on the trend. So the numbers are getting bigger going down group 7. And then why do you think that? That's your own reasons. I think it must be 370, or I might even say 470, something like that, because it is the trend down group 7 is that the melting points are increasing. And the last one was 340, so this one must be bigger. All right. Now, what are the differences then between these 2 groups as a whole? There's really only one difference, is that group 1 are all metals. Think back to the line we drew last lesson. Group 1's over here, they are all metals. And metals, as they get heavier and heavier and heavier, their melting points go down. So we can apply the same to group 2. So group 2 goes from beryllium down to calcium, magnesium, and strontium, and barium, and all those things. It's the same trend. As you go down the metals, all right, the melting points get lower. And these over here are non-metals. And then as they get bigger, so they're going, or heavier, so look at the top numbers as we go down. Yeah, they actually get higher melting points. Okay, right then, guys, before I pack away, there is a 14-minute video I'm going to set you to watch as homework. It's a little video to watch on YouTube. You can watch it on your phone. It just covers everything we've sort of done over the past couple of lessons. And I will be back next lesson.